Arkadaşlar, in this video, I will give you an interesting question, and I want you to first try on your own. Maybe pause the recording or pause the video, and then try to solve it on your own, and then see how you're doing, and then continue with the video. Okay, let me draw my system. Okay, my input is x of n, and I'm sending this x of n to inside of a system. Okay, it's also, there is one arrow like that. H1 of n is equal to b times Dirac n minus 1. Okay, I have this system like that. And then I will send this to H2 of n, which is equal to an un. Okay, and then there is one output of y of n like that. Okay, so and then this thing goes to here. So xn goes to another. It also has a kind of branching, goes to the first system. Okay, system one, and this is system 2. And then there is one other here. The output of this system goes to the other. It adds with x of n, and then this addition goes to the second system, and the output of the second system is y of n. Okay, my system is something like this. Okay, this is like the actual system. Okay, so we have the x of n goes to the big system, and then my output is y of n. And h of n is the impulse response of the system. I want you to find out the actual impulse response, h of n, in this kind of a system. Now, pause the video and then try to solve it on your own. I will continue how I solve it by myself, and I want you to try solving it on your own. Okay. Now, I would like to solve this question for you. You see, x of n goes to the other here. What else is going? x1, like this, plus xn convolved with h1 of n. Okay, now we are adding them. Here we have the xn plus xn convolved with h1 of n. Now it goes to the second system, subsystem, let's say, h2 of n, and my output will be equal to y of n. I hope you understand what I'm writing. This is my input. This is the input to the second subsystem. Okay. So now the trick starts. If you are asked to find the impulse response of a system, what do you need to do? If you put x of n to become Dirac of n, the output will be equal to h of n. You know, if the system's input is Dirac n, the output is h of n. This is what I'm doing here. So instead of x of n, I will put Dirac n plus Dirac n convolved with h1 of n. What is h1 of n? B Dirac n minus 1. Okay. And then this will be equal to, this will be convolved with h2 of n, which is a to the power n un. This is equal to h of n. Okay, I put Dirac n here, Dirac n. I put b Dirac n minus 1 here. And then I put h to the power n un. So let us continue. What is going on here? I should be thinking about doing this part first. Okay, what is Dirac n convolved with b times Dirac n minus 1? Dirac n minus 1 times b, right? Convolution of this, but this one will be equal to just one delay. And then this is our previous Dirac n plus Dirac n convolved with a of n un, which is our h of n. So now I will use the property. If you remember, my property was distributivity with respect to addition. Okay, so I may have this convolved with something with addition. I can change and I can distribute like multiplication, right? Do you remember from multiplication? So if I convolve this Dirac n convolved with a of n un plus b Dirac n minus 1 convolved with a of n u of n, this will be my h of n, right? I used the distributivity over addition property. So if something is convolved with Dirac n, it stays the same. Dirac n is like, it doesn't have any effects in the convolution. It's like etkisiz eleman, no effect, okay? So the output of this part is an un plus, if I'm convolving any function, any signal like that with Dirac n minus 1, that means I am shifting everything here by 1. Okay, instead of n, I will write n minus 1. b times a to the power n minus 1 u n minus 1. So this is my impulse response. A to the power n un, b times a to the power n minus 1 u n minus 1. Okay, this is something like this. This is something like that. 1, like 0, 1, 2, 3, 1 over a, 1 over a square, and so on. Sorry, a square, a to the power 3, if a is less than 1 here and greater than 0. Similarly, now this time I will have, starting from 1, this will be 1 a square, and so on. Okay, and then I will multiply this by b. So I will add these two. So if you are asked to plot what kind of a signal is this, then output will be like 1 here, 1 b plus a, and this is like 1 here. This is a plus b, and for 2, a square plus ab, and so on. Okay, 0, 1, 2. This is n. This is my h of n. Okay, this is all for this example. I hope you got the main idea in this